The reef is still, partly because it's so diverse and partly because it's been well protected for a long period of time, it actually has inherent resilience, but it's under serious pressure. And the main problem at the moment is it's not about one individual impact. So it's not about whether we have a major coral bleaching event in 1 year, which we have had last year. It's about what's been the consequences of the long-term effects of multiple disturbances potentially on top of each other.
G'day and welcome to Season 2 of our Reef in Focus podcast, coming to you from Woolgaroo country and neighbouring Bindle country in sunny North Queensland as always. My name's Lincoln Bertoli, and to kick off our second season, we're doing things a little bit differently today. It's fair to say over the last 12 months, it's been an incredibly busy time for those involved in research and reef management on the Great Barrier Reef, coming off a significant bleaching event in our previous summer. There's been some significant reports released, not only from the Reef Authority, but our colleagues at the Australian Institute of Marine Science. And that's coupled with probably 10 to 15 years of a number of impacts ranging from tropical cyclones, flooding events, and significant bleaching events on the Great Barrier Reef, as we've touched on. Luckily for us, we're joined in the studio today by two men at the forefront of marine research and reef management. From the Reef Authority, our very own Chief Scientist, Dr. Roger Beeden. Hello, mate.
Hello.
And from our colleagues at the Australian Institute of Marine Science, the Director of the Research Program at AIMS, Dr. Dave Wachenfeld. Hello, Dave.
Hello, Lincoln.
Now, as we said, there's plenty to get through and we've got a lot to talk about. So, Roger, I want to start with you if we can. We now have access to more information on the Great Barrier Reef than we've ever had before, essentially. So how important is this in terms of reef management that we have access to this data, and how does it frame what we do on the Great Barrier Reef?
Well, it's a great question, and you're absolutely right. I mean, it's one of the great values of the advances in technology that have happened over the past sort of few decades is that we have insights into things like water movement in the marine park in a way we've never had before, high resolution spatial mapping, like all the way through the water column, etc. So there's lots and lots of insights that we're getting from that emergent science. And it's becoming increasingly important because even though the system has always been incredibly dynamic and complex, we're seeing more and more pressure on it, particularly as a result of a changing climate. And so having an understanding of what's going on is crucially important so we can let everybody know what's happening, but also, perhaps more importantly, so that we can frame and target our management to best possible effect. And that's getting increasingly important as we see the need for more and more types of interventions alongside the sort of long-term management actions that we've had in place for many years, like the zoning plan.
So essentially from that, it not only means we can monitor, I guess, the current condition of the reef, but it helps us model what the future looks like moving forward.
Well, that's exactly right. And I think that, again, people will be very familiar with using kind of modelling tools like all the time. So things like weather forecasts, for example, incredibly useful for us. The climate models that are in there and ecosystem models really help us think about what's likely to happen in the future. And the challenge of a changing climate is that more and more we have to make these sort of prognostic actions, or take these prognostic actions. What's likely to happen is how we want to drive what we're going to do. And so, having supercomputers, because I mean the maths has to run on computers, and in many cases incredibly complex and requires that kind of technological power to actually be able to do it, but then coupling that with monitoring information. Very fortunate we've had long-term monitoring for a long time, and my colleague Dave will be able to give some insights to that. But increasingly we're seeing a tight marriage between monitoring, what's actually happening today, and then how that can inform models of what's likely to happen in the future. So, this is becoming more and more sophisticated and more important.
Dave, touching on what Roger mentioned there in terms of working in close partnership, the Reef Authority and AIMS have worked together for the better part of half a century. How important is working in that close proximity in terms of not only management, but conservation and looking to the future?
I think one of the challenges that faces us is that the reef is such a vast and complicated ecosystem, and it's beyond the resources of any one organisation to monitor and manage that in isolation. So obviously here in the room, we've got AIMS and the Great Barrier Reef Marine Park Authority, but also when we think about the range of scientific partners, There's the Bureau of Meteorology, there's the CSIRO, there's even an American organization called the National Oceanic and Atmospheric Administration. And the reason why that's so important is that the full breadth of that partnership brings a range of technologies and capabilities to bear. So when we look at the Great Barrier Reef, which, let's remember, is bigger than 2/3 of the countries on the planet, we can actually use satellites to look at the temperature of the entire ecosystem. And we do that in partnership with the Bureau and with NOAA in the States. We work in partnership with the Integrated Marine Observing System. They have a series of gliders, which are basically automated underwater unmanned submarines that go off and measure things like salinity and water quality, but most importantly, temperature, because of course the satellites are only looking at the surface. And we can send these gliders down to look below the surface and see what the temperature is. We still, AIMS and the Reef Authority together, put people together in light planes to do surveys of aerial surveys of coral bleaching, because that's a great way of covering a big distance very quickly. And then the final technology, if you like, in all of this collaboration is really the traditional one of just putting people in the water on snorkel or scuba. Sometimes we use scooters so that they can cover more ground more quickly. But that, at the end of the day, is still the way that you have to go and have a look close up at individual corals. So all of that collaboration allows us to provide the science that is all about protecting coral reefs better into the future. And there's three elements of that that I think are absolutely critical. So one is we're beginning to look at blue carbon, which is carbon that is stored and locked up in marine and coastal ecosystems, and to see how those coastal ecosystems are storing carbon and whether we could actually accelerate those processes so that we draw down carbon dioxide out of the atmosphere to further limit climate change. So I'm talking about things like mangrove forests, seagrass beds, seaweed beds, but even very unattractive looking things like simple mud flats can actually be incredible carbon stores. Then, of course, there's the science that we're doing that underpins what the Reef Authority does today. So particularly Crown-of-thorns starfish control and zoning. We're out there monitoring the effects of those management activities and helping understand how well they're working. And the third and final piece, which is a huge collaborative effort, is looking into R&D for the next generation of tools, because we know the planet is warming. We do not think that we're going to stop emissions quickly enough to really curtail future warming. We need to get ready for a warmer planet. We know that as good as they are, our modern protection techniques are probably not going to be enough on their own. So we're looking at a new generation of adaptation and restoration techniques, including a wide range of collaborations with universities and other science partners to see what that next generation of coral restoration and conservation tools will be.
Yeah, okay. So these partnerships really are critical. And can I ask you, it's a great lead into our next question, but before we move on, can I ask you, working in this area, is it difficult sometimes to portray the scale of the Great Barrier Reef? Because, you know, if you go for a swim out on the reef, you see the beautiful corals and it looks fantastic at the moment. But when we're seeing these changes and these impacts and the pressures that the reef is facing, is it Roger, from your point of view, difficult to portray that to people outside of reef management or Great Barrier Reef research, for example?
I think it's difficult even if you do work in this space. I mean, the thing that's always kind of strikes me when you talk about a system that's something like the size of Italy or Japan is, you know, that's you know, it's almost an incomprehensible area in some ways, but then it's made more challenging by the fact that there's this layer of water there. So when you look at it, you see the surface of the water typically. As you say, most people's viewpoint of the reef, if they go out there, is through a little mask, and half the time they're worrying about whether it's filling up with water or not. But I mean, then they're looking at a very small part of a reef. And so the concept, and we use the term reef, capital R, to mean the whole thing, and then a reef can be an individual part of the reef, one of the 3,000 reefs, or it can sometimes be a relatively small area. So people see a very small proportion of what's there. If you saw similar impacts occurring on land, it would be much more visible. When we have flood events or major bushfires and the like, you can see that from the air. It's very, very clear. Whereas you can have very widespread, devastating impacts of tropical cyclones, crown-of-thorns starfish, coral bleaching events, etc. And it's out of sight and often out of mind for people. So I do think the scale issue is one that all of us find a challenge to convey, and it's why often we'll use terms like, it's the size of X number of football fields, or like to try and get people to understand that. Perhaps the simplest way of thinking about it, though, you can see this thing from space, and it's made by small organisms clubbing together and making this gigantic kind of structure, living structure that's been self-replenishing itself for millennia. And that's what makes it so incredible. And that's only the foundations of it, and doesn't even speak to all of the biodiversity. But the scale is a really important thing for to notice. And I might just add to that, it's not just the spatial scale, it's also the temporal scale, the time scale. I mean, there's many corals. I mean, Australian Institute of Marine Science have cores from massive old long-lived corals that can be 1,000 years old, and you can take cores out of them to see what the history of them has been. So many of these things are changing on very slow time, not like human time scales. So a lot of time we want an answer really quickly as to what's happened to the reef, and it's actually, well, the answer is it takes time for that to play out, and particularly because there's so many different species that make up the biodiversity of the reef. So the time and space scales are really important when we talk about the Great Barrier Reef, and often some of the confusion is because people will be talking about a different time or spatial scale to somebody else when they're meeting something entirely different.
Yeah. And Dave touched on it previously that these partnerships are critical, and we often say at the Reef Authority that, we can't do it alone. We've just released our 5-yearly outlook report, which is an in-depth look at, the health pressures and likely future. But why is the outlook report so significant? What does it tell us about the reef and help to frame our management moving forward?
It's a great question, and I mean, again, I think that I'm glad that I was saying something about that time scale. So the outlook report is probably a little bit like the Australian Institute of Marine Science's long-term monitoring report. That's on a specific thing. This is on the ecosystem condition as a whole, as you say. We check in on the reef all the time. I mean, it's a 365, 24/7 operation to manage the reef. But what we have done, and this is now the 4th outlet report, is to systematically assess the condition of the key components of the Great Barrier Reef, so the main habitats and species groups that sort of underpin its condition. And we've evaluated those, and it's important so you can track what's happening through time. The sobering reality of the outlet reports is that we've actually been noting the critical challenge of climate change for all of the time those reports have been produced. The first one was in 2009, and in fact, actually there was certainly concern about climate change well before that. And the reason that concern remains, and it's considered to be the most significant threat to the Great Barrier Reef, is because of the critical temperature sensitivity between coral, the foundation builders of much of the reef, the coral animals, and then the little algae that give them most of their food. So that temperature sensitivity, I mean, they're a bit like Goldilocks. They like the conditions to be just right. It's not just temperature, it's also water quality, etc. But that has, I mean, it's a sort of, because they're foundational, it has major implications, and that's why the projections of the outlook report remain, which is that the outlook is actually very poor. That's juxtaposition, though, with the fact that we've had the reef is still, partly because it's so diverse and partly because it's been well protected for a long period of time, it actually has inherent resilience. Resilience is sort of like an elastic band. You can stretch it and it bounces back again. And so the capacity of the system to be able to come back to something like it was before, even though it has these disturbances, is sort of baked into the Great Barrier Reef, but it's under serious pressure. And the main problem at the moment is it's not about one individual impact. So it's not about whether we have a major coral bleaching event in 1 year, which we have had last year. It's about what's been the consequences of the long-term effects of multiple disturbances potentially on top of each other. That's why the outlet report is important, because it helps us see through that longer-term trajectory and what's likely to happen based upon modelling of climate futures, but also using information like comes from the long-term monitoring program that Dave oversees, and also the equivalent in the inshore areas. So that's a long answer to it, but it is a way of systematically looking through the complexity that is the massive, amazing place that is the Great Barrier Reef, and understanding what's happening now and what's likely to happen into the future.
Yeah, okay. Dave, can I ask you about that in terms of resilience? You mentioned before that the reef as a whole is much more than coral. We're talking about seagrass meadows and estuarine areas, islands, etc. Over at AIMS, you head up the long-term monitoring program, which is the biggest and most comprehensive or extensive coral monitoring program anywhere in the world. In terms of resilience, when you're looking at coral over the last 50 odd years, what are you seeing? What did this year's findings, for example, say about coral cover on the reef at the moment?
I think the key thing about our long-term monitoring of the Great Barrier Reef is exactly what Roger was talking about before. It's capturing the spatial variation and the variation in time. Now, the Great Barrier Reef as we know it has existed for about 6,000 years. We don't have data going back quite that far, although the coral cores help. But we now have almost 40 years of regular annual monitoring of a core set of reefs that allows us to track the trajectories of the Great Barrier Reef. And as big as it is, and obviously we don't monitor all of those reefs, but what we do is we are very careful to capture the north to south and the east to west, or the inshore to offshore variation. So acknowledging that not all parts of the Great Barrier Reef are the same, it's not one big homogeneous system, it's really variable. We spread our effort out so that we can catch the spatial variation. We've been doing this for 40 years so that we can capture the variation in time. And I think the key is that as much as you might want to look at the results in any one year, so for example, this year you might say, well, now we're monitoring the reefs, it's sort of late 2024, we want to know what the impacts are of the bleaching that we had last summer. Perfectly valid question. But the real issue is, how does this year sit in that 40-year time horizon? Because it's that long-term view that actually tells the story of what's happening on the Great Barrier Reef. So for about 20 years, yes, the health of the Great Barrier Reef varied up and down a bit, different in the north, the central, and the south. That's generally how we cut it up to summarize things. But those variations weren't very big, and they weren't happening very quickly. Then we started to see a series of really serious climate-driven impacts. In the beginning, it was mostly cyclones, but then it was more heat waves. And so in the last 15 years, we've seen a kind of gentle up and down undulation in reef health become a much more jagged kind of roller coaster ride, with the lowest lows we've ever seen, but then followed by the highest highs. Now, how on earth can that happen? Well, the truth is, two things are going on. The climate is changing. That's driving extreme weather events. They're creating impacts that are bigger than anything we've ever seen before. And as Roger said, it's not just one impact, but it's the accumulation. So in the last summer, we had 2 cyclones, flooding, and a marine heat wave that led to coral bleaching. So it's the accumulation of those impacts leading to the lowest coral we've ever seen at times in the last 15 years. But the reef is still a resilient ecosystem, so it can bounce back. As big as those impacts have been, we're seeing the reef demonstrate enormous recovery potential. And so, in fact, in the last 3 to 4 years, we've seen some of the highest coral cover statistics we've ever seen. But when you look at the whole time series, this gentle up and down undulation of reef health for about 20 years has suddenly become this quite jagged roller coaster, lurching downwards, lurching back upwards. And the really scary thing for me is that that is exactly what our modeling and forecasting has told us was going to be the early stages of impacts from climate change. And of course, today, the global average temperature increase is about 1.1 degrees centigrade, but we know we're going to be at 1.5 in the early 2030s. And on current commitments to reduce greenhouse gas emissions, we're going to be at more than 2.5 degrees of warming by the end of the century. So as much as I take heart from the resilience that we see in the long-term monitoring that we have on the reef today, we know that it's not going to last as we keep warming the planet. And that's the big concern.
Yeah, okay. And we often say, in terms of those impacts, that as you both said before, the reef can recover, but it needs those disturbance-free periods, if you like, for the coral to come back, or for the entire ecosystem to sort of bounce back. Is that still how we think of it moving forward when we're seeing more frequent impacts, that provided it does have these disturbance-free periods, it can adapt to a changing climate?
I think the short answer to that is that we don't entirely know. I mean, there's some important signs of that, and it's a very active area of research. And I mean, we're very fortunate to have such good collaborative research going on within Australia and actually around the world. And there are many efforts to look at that question. I think given that we don't know what the answer is entirely, and there's substantial uncertainty depending upon where the climate actually gets to over time, it's more important than ever that we do the things that we know actually help to protect that bounce back capability, its resilience that's actually already there. And we know, so some of the things in the AIMS long-term monitoring report about that Dave's talking about this sort of more jagged, ups and downs. I mean, actually the big ups that we've seen recently are driven by particular types of corals. And there's something like 450 species of hard corals found on the Great Barrier Reef. Those are the ones that build the sort of structural framework of the reef. Of those, about 100 and something actually are types of fast-growing corals that are particularly abundant in this recovery that we see at the moment. They're really important. It's a bit like after a bushfire, seeing what grows back quickly. It isn't necessarily the old growth trees that come back quickly, obviously. It's actually these fast-growing things, and that's a lot of what we're seeing there. Importantly, though, you want those things. It's not that that's a bad thing. It's a good thing, because you actually that what they produce in terms of structure is really important as being the homes for much of the other biodiversity that reefs are known and loved for. And so the reason where I'm going with this is it's keeping and protecting those types of corals, the ones that can come back as quickly as possible when you have more frequent disturbances, is going to be crucially important. That's why we've put in place in the course of the last few years a very much ramped up Crown-of-thorns starfish control program, and that we're putting that on top of many decades of improvements in the protections of particular areas of the park through zoning, the compliance with that, so making sure people know that what rules they should follow, where and when, because we know both of those substantial measures actually protect that resilience capability of the reef. And particularly where we're talking about these fast-growing corals, are the ones that Crown-of-thorns starfish, this sort of voracious coral predator, love to eat. And so the last thing you want is that the ones that actually survive something like a coral bleaching event, which at the moment you can't stop, you want those ones to stay alive, because they're the ones that are likely to produce baby corals that actually may be slightly less sensitive to temperature in the future. So it's how all these things come together is actually the key question for us at the moment. It's the thing that is so important about having science and long-term monitoring records. So for example, Crown-of-thorns starfish control program, we know that works as well as it does because AIMS monitored the previous outbreak in the early 2000s when we didn't really have very much control in place. So you can compare what happened then with what's happening now, and then that actually look at the other disturbances that have occurred and then isolate the information that shows, well, if you put enough culling effort on the right reefs at the right time, then actually you can have a major influence upon coral cover trajectory as improvements, even in the presence of other disturbance events. That does not mean that there's no silver bullet in that. It doesn't mean that it's going to offset the changes that are likely to come as we see 1.5 degrees and more, but it does mean that there's likely to be a lot more habitat, coral and other species kept or buy time for those things to potentially adapt to a changing climate. And that, is the main game at the moment. How do we buy time for the reef to adapt to these really substantial pressures?
Yeah. And Dave, you touched on it before, and I'll come back to you around the Reef Restoration and Adaptation Program and some of those technological advances. But I guess for our listeners' point of view, Roger, I'll ask you, the most important question is, we're seeing these impacts and we're seeing these disturbances and the effects it's having on the Great Barrier Reef. But we know that a lot of these programs are working, so there is hope for the Great Barrier Reef absolutely moving forward.
Yeah, look, absolutely. I mean, I think there is no doubt in my mind, and I think in many my colleagues' minds, that Undoubtedly, the things that we do today will make a difference to the trajectory of the reef going forwards. That doesn't mean that the trajectory is a good one. The trajectory may well be poorer than it is. That's exactly what the outlook report says. It says the future trajectory is very poor. Our job at the moment, again, is to buy time for the reef to adapt as much as possible. We know what many of the ingredients are to support that resilience. We also need global action on climate change. And again, even in that space, there is lots of action happening. Go and look at how many people have adopted solar panels on the roofs of their houses, et cetera, et cetera, et cetera. There is action happening. Whether it's quickly enough or not is another matter. But our job is to use the science that is available to us and to work with colleagues to get as good science as possible to maximise the resilience of the Great Barrier Reef. So I'm certainly hopeful, because we've got really good evidence that many of the things that we're talking about actually have already worked. I think that the question is, and the reef is still a very vibrant, amazing place right now, but that coexists with a prognosis that is actually poor.
Yeah, okay. Sorry, go on.
I think that it's important to remember, we often talk about sort of long-term, broad spatial scale averages, and we talk about the resilience of the system, and that's true. But when we start drilling down to look at individual reefs, individual locations, there are already early signs that those recovery windows that you spoke of, they're not as long as they used to be. Not all reefs are recovering. And as we look at different individual reefs, we can see things like there are reefs certainly that lose a lot of coral in let's say, a marine heat wave, and they rebound with exactly the same kind of coral in 5 years. It's astonishing. It's brilliant. There's other reefs that don't rebound.
Yeah.
There's other reefs that are rebounding, but with different kinds of corals. We've now got emerging evidence on inshore reefs that actually coral reef fish communities are changing, and they're becoming less resilient. That's just emerging science now. And so there is enormous hope for the Great Barrier Reef for the future if we choose to do more, particularly at the global scale with greenhouse gas emissions.
Yep. Which leads into our next question. I think you both mentioned the term, there is no silver bullet, but Roger, you mentioned we are seeing corals that are perhaps spawning and they're a little bit more heat resistant. And Dave, you talked about different technology that's possibly fast tracking this sort of thing in a research and development sense. So moving forward, as we asked Roger before, there is certainly hope for the Great Barrier Reef.
Look, I think, first of all, people should remember to put corals in a very long-term global context. Corals have been around on the planet for millions of years. According to the fossil record, they've had periods where they boom, so there's just corals everywhere and coral reefs are thriving, and other periods where they bust and they're not doing so well, but they don't disappear. And at the same time, even today, we've got corals in other parts of the world, so places like the Red Sea, the Gulf of Oman, parts of areas nearer to the equator, where corals are surviving at temperatures higher than on the Great Barrier Reef at the moment. So it's not that corals don't have the capability to withstand higher temperatures and difficult conditions. It's all about the time frames in which we think those responses are going to happen. So what we need to realize is we're changing the climate. Humans are changing the climate much faster than it's ever changed before. Mm-hmm. Can corals adapt? In principle, absolutely. Can they adapt quickly enough to the rate of change that we're implementing? It's not known for sure, but it seems unlikely, and they would have to be adapting a lot faster than they ever have before. So what we're trying to do now is to take the natural variability that we know is there in corals. Two corals might look the same, but perhaps their chemistry, their physiology, the aspects of their anatomy, their symbiosis with the microscopic algae that Roger mentioned before, all those things can be different, and you can have two corals that look the same. They are very different in their thermal tolerance. Yep. Now, we need to take that natural variability and enhance it and speed up natural processes to give corals the best chance they can have into the future.
So if we essentially roll a lot of that together, and Roger, I'll start with you. What are some of the management strategies or resilience-based management techniques that we're essentially rolling out at the moment and we're seeing the positive benefits from?
Yeah, so I mean, it's again really important. That concept of resilience-based management is thinking about we've always managed at a sort of ecosystem scale. It's called ecosystem-based management, but then thinking about what's likely to happen in the future. Can we manage for that bounce back ability that was mentioning before? So some of the key things in that space, there are already a bunch of initiatives that are in place in the marine park that actually are core to protecting the resilience of the entire system. The primary one of those is actually the zoning plan. So the fact that we have this network of protection through the entire reef that covers all of the habitats, and it means about a third of it is not open to extractive use in terms of fishing. And we know from the long-term monitoring program record and the analyses of it that actually that improves the ability of not just fish communities, and because that's the main thing that's different in those places, but actually also the coral communities that have actually found that, and their ability to bounce back more quickly from coral bleaching events, from cyclones, from crown-of-thorns starfish outbreaks, and from outbreaks of coral disease. So having intactness of a system, the more that actually the things that are supposed to be there are actually there in the right proportions, actually seems to give that elasticity to the system to be able to absorb those knocks and shocks. So that's critical. And the great thing in the Great Barrier Reef is that we have an extensive compliance program. We'll catch people if they're not doing the right thing in terms of what, not obeying the rules of what's in those areas, whoever they happen to be. So that's crucial. It's sort of like the underpinning fabric of your sort of multi-year superannuation fund, if you like, which is kind of what our management is. It's lots of different investments. And then we're supplementing that with things like the Crown-of-thorns Starfish Control Program. So that's a pressure that, even though it exists over major areas and over large time scales, we actually have techniques now that can control the numbers of crown-of-thorns starfish to a point whereby they're not putting as much downward pressure on coral growth and reproduction. And that's crucially important to support that resilience. So there's a couple of the strategies that they're the sort of things that fit within the recently published Great Barrier Reef Blueprint 2030, which is really about how we respond to the knowledge about climate change that's captured in the Outlook report and many, many other types of reports, what we should put in place, how we bring our management actions together. And that sits under sort of 5 key areas. First one is about building and protecting the resilience. There's another key component, which is actually about mitigation, what the world and we need to do in terms of tackling the underlying driver of climate change and increasing greenhouse gas emissions. That's absolutely critical. The building resilience is really important, but the reality of the pressures are coming on stronger and stronger as a result of climate change. So they need to be, both things need to happen in tandem. And then on top of that, we need to improve our management with traditional owners, because their way of looking at sea country in a holistic way is exactly the kind of approach that we need more broadly. And we need to work with traditional owners to understand how we can best implement actions, work with the other members of the community about what they can do individually in their local areas, because not every area of the reef is the same. And then we need to modernise our management. And we've been on a continuous improvement journey for nearly 50 years now, and we're not going to stop anytime soon. We're going to always look to see how our rules that we set, the regulations that are in place, what's allowed to happen, where it's allowed to happen, what we target, that's best optimized for the kind of supporting of resilience in the future. So it's those 5 key areas, and I really encourage people to have a look at the documents, because some of the things that are under each of those 5 headings are already existing, and some of them are new actions that we will look to bring on stream over the next few years in the marine park.
And Dave, can I ask you, Roger touched on, these tangible sort of improvement management strategies and aspirations that we're working towards in terms of reef management. From an AIMS point of view, are there, if we can get your crystal ball out and look into the future again, what are you guys building on, or are there technologies that you're looking at that can help to build on this into the future?
Yeah, there's no question that we're doing science that underpins the management strategies of today, but at the same time, our understanding and our forecast of the futures makes us realise that as much as the management strategies we use on the Great Barrier Reef are world-leading, they're not going to continue to be as effective as they are today as we continue to warm the planet. So we're working on the fact that we know that there is enormous genetic diversity, both in corals, but also in the microscopic algae that live in corals and actually give them most of their food and their energy. Both of those organisms, the algae and the animal, the coral, have got thermal limits, but those thermal limits aren't the same everywhere. So, for example, over almost 2,500 kilometers between the northern Great Barrier Reef and the southern Great Barrier Reef, there is a very big difference. Northern Great Barrier Reef corals can take higher temperatures than southern Great Barrier Reef corals. So there are genetic differences there. There are ecological differences. We need to use our understanding, our growing understanding of the genetics and the ecology to work out how we can take natural variability, enhance corals' ability to adapt to a warming world. And that means both trialing things out in the field on the reef, but also doing work in aquaria like the National Sea Simulator, which is a huge experimental facility where we can play with things like temperature and water chemistry and water acidity to see how corals form and perform in different sorts of conditions. We need to package all of that up with novel engineering, because although it's fine to learn that if I take a coral from the northern Great Barrier Reef, it will survive better in the southern Great Barrier Reef because it's tougher from a thermal perspective, or I can breed microscopic algae in the laboratory that make corals more thermally tough. That's all great, but we've got to do this at a meaningful spatial scale, and that's where the engineering comes in. New materials, new processes, the ability to take our genetic and our ecological understanding and apply them at a much bigger spatial scale than we've ever done before. We've got to bring all of that together and apply it to the Great Barrier Reef as the climate is warming.
So can I ask you this, keeping that in mind, and we're getting the wrap up from our producer, we're almost out of time, but can we fast forward 10 years, keeping that in mind, and you're in the water, you're going for a snorkel or a dive, it might be tough for you to answer, but what are you expecting to see 10 years from now on the Great Barrier Reef?
I think the shortest answer is that we don't really know. We do know that everything we're doing today and everything we're planning to do into the future will improve the future for the Great Barrier Reef. But exactly how will things unfold over the next 10 years? I don't have that crystal ball. What I think two things that are for sure. One is that the Great Barrier Reef will become increasingly variable. In 10 years' time, I'm sure you will be able to go and find bits of the Great Barrier Reef that are spectacularly beautiful. They are healthy, vibrant coral reefs, just like you'd expect to see after you've seen Finding Nemo. But you will also be able to find other places that are badly degraded, that have lost most of their diversity and their attractiveness. The big unknown is what's the balance between those two things. But obviously, everything that AIMS and the Reef Authority are doing is all about pushing that balance in the right direction.
And Roger, same question. You've mentioned once before that these management strategies, these techniques that we're rolling out are working. Would you care to add to that? What do you expect to see 10 years from now?
I think that the answer that Dave gave about we don't quite know, that's for a variety of reasons. And one of the things I'd sort of really reflect on is that it will depend on whether we have a sequence of serious disturbance events. We've seen that in the past, and then we haven't seen as much of it in the last few years, which is actually what that sawtooth pattern that Dave was talking about in some of the long-term monitoring records. So if we have a considerable sequence of very severe events on top of each other, then on average, I suspect what you'll see is a much degraded system with some pockets that are actually still pretty incredible. That said, if we continue to have a relatively reduced, not as many disturbances, or they're not as severe in that 10-year window, then I suspect that we'll still see the kind of rapid recovery and, that we've seen documented in the long-term monitoring record. So it will depend upon what happens with that sequence of events, where you happen to get into the water. Undoubtedly, I think there will still be pockets, because there is no doubt that the resilience of the reef is still there. And actually, I'd also suggest that that's not by accident. So my point about there are key measures, there were some very foresightful brave decision making around the rezoning program, which was controversial at the time, but undoubtedly has supported the resilience of the fish and coral and other communities that make up the Great Barrier Reef. And the reef today is better for it. But then also some of the things we've done in the last 10 years. You know, there is no doubt that there is a lot of this fast growing plate and branching coral on the reef because we've actually put a serious dent in the outbreaks of Crown-of-thorns starfish on many of those reefs. And I expect those measures to continue to pay dividends over time, and that we will still find some really incredible spaces. Just there probably won't be as many of them because we are likely to see more and more disturbance.
Yeah. Look, we're out of time. We could talk about it for hours, as always, but incredibly insightful. Thank you very much, gentlemen, and look forward to catching up again very, very soon.
Thanks for your time, Lincoln. Thanks,
Cheers.
Dave.
Thanks, Roger.